All right. Today is the first edition of Sean's homework presented by Straughter Guthrie, aka Batman Asama. Check out his channel. We're going to make sure that he has way more videos, because if he's going to be giving me this homework, he's going to have to be online too. So, read this for the transcript. We introduced Buffer of Thoughts, a novel and versatile thought-augmented reasoning approach for enhancing accuracy, efficiency, and robustness of large language models. Specifically, we proposed MetaBuffer to store a series of informative high-level thoughts, namely thought template, distilled from the problem-solving process across various tasks. Then for each problem, we retrieve a relevant thought template and adaptively instantiate it with specific reasoning structures to conduct efficient reasoning. To guarantee the scalability and stability, we further propose Buffer Manager to dynamically update the MetaBuffer, thus enhancing the capability of MetaBuffer as more tasks are solved. We conduct extensive experiments on 10 challenging reasoning-intensive tasks and achieve significant performance improvements over various state-of-the-art methods. 11% on Game of 24, 20% on geometric shapes, and 51% on checkmate in 1. Further analysis demonstrate the superior generalization ability and model robustness of our BOT, while requiring 12% of the cost of multi-query prompting methods, e.g. tree/graph of thoughts on average. Notably, we find that our Llama 8B BOT has the potential to surpass the Llama 70B model, which is pretty cool, because I can't run. I've got the Max with 48 gigs of memory, and I can't run the 70 billions. I can run the 8 billions. Anyway, all right. So let's go to the code. Okay, we got bot pipeline. So if we look at this, we got Torch, MetaBuffer. So I don't know what they're using Torch for. Let's figure that out first, because that seems Torch type, data type. Interesting. All right, but we can keep a look. Get respond. Okay, so they're the assistant, messages, pipeline tokenizer, chat template for tokens to IDs. This looks like it's Llama version. Okay, generated outputs, BOT, right? Pipeline, problem ID, get respond. Okay, we will later update the embedded retrieval version to support more. So they're baking in the problems. Reasoner instantiation. Temporary using selection method to select answer extraction method. Okay, the problem list up here. Formatted input. Okay. You got your different stuff. So, I mean, this looks pretty good for converting it to DSPi, I guess. So let's look at the meta. Oh, we've got a big prompt. Okay, big prompt alert. And we've got non-English alert. Okay, we got the triple backticks. Okay. Run benchmarks. It's just running it. Templates. Okay, so this looks like a lot of pre-done work. So, yeah, I don't know. I mean, it looks like a lot. This is very, very. This is not like, while they said generalized, this doesn't look very generalized. So I think we're gonna have to let him know that this is very hard coded. So what I'm doing is I'm just saying to him, looked at it on stream, mostly hard coded prompts. So far, homework not passed. Okay, open research assistant. Okay, automate discovering insights from research papers. Okay. information found, buy a domain in the landing page. Okay, front end, let's see what it's made with. Bootstrap, font awesome. JS deliver, loading animation. Okay, so open RA. Okay, also this, I don't know where the code is, but this just looks like a HTML page. So homework failed on that one. Okay. This was an interesting looking one. Planners, PDDL is something that I was looking at because we need, if we go back to our Gantt agent, so we'll close all this up. Close all this up. We got our data writer retriever. We'll go back to our Gantt agents, right? So we look at our Gantt agent. Where we were at yesterday is we have task, plan, and execution, right? But the planning was just generic information. It wasn't like real planning. Like here we have this diagram. We weren't really getting into implementation details of tasks. So let's really go into view the PDF, right? So it's pretty long. We got argument types, domain goals, content examples, domain. Okay, this looks like some very good stuff. So what we're going to do is we're going to grab these things, and this we're going to start converting into DSPi modules and stuff. And so again, this is like very specific to a certain problem set, but we're just going to work with it. So we got a bunch of text to work with. So we're copying it. We're going to go to ChatGPT. We're going to say, I need help turning my paper into Python code. Start there. I am doing the planning. So I'm just letting him know. Maybe he'll come on stream. All right. So we got queries, example. Okay. So first, let's convert this into one module that I can run. Right. I figured out the code. So we're going to get this working, and then once we get this working basically, we'll query. So it looks like we're gonna have to add PDLPi and Klingo, which sounds like fun. More stuff. So let's PDDLPi and PA Klingo. And we're just going to run potest to make sure that nothing broke, that those imports aren't breaking anything. So now we've got our copy code. So we're going to go to the, and we're just going to create a Python file called PDL planning. and we're just going to run it. Okay, so yeah, the OpenAI API. So instead of OpenAI, we're going to just delete it and see creation complete, translate to ASP. So, okay, so what we need is to create a DSPi module. So what we're going to do is, let's find if we already have a module that's something related to this. Look for something like planning or query generator. Time series anomaly detector. Okay. Gusty. That was an interesting one we did for a second. Okay, this is an interesting one. All right, yeah, we're going to take this and we're going to say convert. We're going to say convert to a DSPi.module. Okay, so we're just gonna keep breaking it down. So it looks like we need to create a domain file and a problem file. So I need a DSPi module to create the domain files and the problem files. So it's getting a little confused. So it's merging merging them. So what we're going to say is, let's split each module into its own file. Period. Pay close attention to the structure of the module that I showed you and do not deviate from its patterns. Each should have its own signature that is then used in the module. Perfect. Yeah. Better. Okay, and instead of copying and pasting, what we're going to do is we're going to show this DSPi PyGen module help. Oh yeah, we're going to do help for module new. And watch this. This is where it comes in handy. You can do this. Use this CLI command to create the 3 modules. Yeah, let's see if this works. You might not need the double quotes. I don't know. I've never tried that. Oh, I guess you don't need the double quotes. Learn something new every day, right? Yeah, see. So we got that module created. This module created. This module created. Okay. And now we can go to generate PDL module. Which one is this? Okay, this is domain. There we go. Okay. Then we go to here. Got that. And process queries, then we need translate to ASP. Okay. Okay. So now we got our modules. And so module folder, let's just try this out. So we'll go back to here, planning, and we'll delete this. We'll just delete these. Oops. Okay, so we're looking for domain file. Okay, so now, okay. So now we've got, actually we'll use the call functions. So we'll delete the, I know I delete these things a lot. But one day we'll get back to using them, I'm sure of it. But for right now, the reason why I delete it is so that I can throw it into the language model without getting confused. So we're going to give it this. Okay, so we can say, can you change this main function and module to work? Okay, so it doesn't get the problem file right. Problem content. No. You're not understanding. There is no problem file on the file system. We need to generate that using the DSPi module forward function. Okay, it's still not getting it. Okay, so let's start off with something that generates a DDL file. So let's go to here, to the paper, and we're going to find Argument types. In context, domain PDL. All right, cool. Okay. So we're going to take this again, right? We're now going back to the beginning. We're going to take it. And we're going to say, I'm confused. So we're going to say, I need you to explain how the code you're showing me maps to this text from the paper. And what we're going to do is we're going to do that triple backtick thing where we say paper, right? So that we give it specific reference. Okay, so it's not understanding. So let's start from scratch. Say paper. What would be the PDDL file text to be loaded from the file system based on my paper's text? Yeah. Okay. Okay, so it looks like we're creating these action APIs, charge lookup APIs. Okay, we're getting somewhere now because I can. This makes sense to me, right? So now watch this. If we were going to create an open API file to match this, what would that file's YAML look like? Now we're getting somewhere. Because I know how to create open API files. I don't know how to create PDDL. Okay. So, is this correct open API YAML? Let's check that, right? First, before we go. Yeah, let's just take a second pass to make sure that it works. So what we can then do is say, create a Jinja template that will take a open API file and render it to PDDL based on the paper. Now I think it knows what Ginger is, but because that's the thing is open API to like agent stuff. It's definitely something that I was thinking about. So we can call it P open API, and so we can call it open API dot. Yeah, and then we can copy this, paste it here, and we can see that the typos, otherwise it would break, because if we do this, and then if we, so actually it doesn't check it. So it doesn't check it, so the check marks are incorrect. Oops, whatever. All right, so let's now go to our template. So we go to our file. Grab our template. And we run it. Let's make it so that the main has a live templates. And we can go to user. Do we even have a user? No. Python. We can go to main, because we always seem to need a new line at the end. There we go. All right, there's that. Now we can run it. Okay. We'll say is this valid? Okay. So here's the thing. If we have to run it through here to fix it up, that's a step that we would have to add in the future. It's similar to where we got with our Mermaid.js, right? So we got our GenOrch Planner PDDL. Now let's see where it is in here. Okay. Domain rules, right? And so we can say, does this have domain rules? So domain rules only comes up once. So, and we can say, where do the domain rules go? Because I don't really know PDDL. Okay, so we got our query ASP. So we got B1 done, got B2 done. Now we're going to look at C. Okay, cool. Okay. Now, how does this factor in? So I have a theory that I want to use with our Gantt agent. Now, we're going to take our Gantt agent and say, now using this Gantt agent and a Gantt chart, wouldn't it be possible to express what needs to be done in a simpler way? Different. Right, because if we can, this is what I was thinking about, is with the dependencies in the Gantt chart, things like that. Okay, so it just repeated. So change the Gantt data, yeah. Change the Gantt data to match that of the PDDL. No, the other way around. No, I want the PDDL to be converted into a Gantt chart. Right. Okay. So we want the accounting example of the accounting example. Because what I want to do is make the example of task management for my company. Okay. Okay. Do not duplicate code, just import it. Right? We want it to import the existing. Just perfect. See? Okay. Actually, just provide me the JSON representation of the PDDL that would go into the Gantt model. Yeah, see, no. What I want is Let's think about this step by step. Period. What I want is to have a system that uses a language model to generate the data for the Gantt chart, for the agent to then read that chart to do the work. Essentially separating the planning from the execution, but knowing how we want to execute in the first place. Because, yeah, I don't know what the fuck. Oh, shit. My language. I can't watch it on this computer now. I don't know how to parse the PDDL, but I can parse it with JSON. All right. Now let's switch the task from. Let's switch the task to the fact that I have a list of people that are subscribed to my Loom workspace that I want to have subscribed to my YouTube channel. Period. I can download their emails as a CSV. I then want to have the agent be able to create the emails to let them know how to subscribe and where to subscribe with some personalization, and then send those emails. So actually, instead, let's have a agent that inherits from the Gantt agent. That way we don't have to repeat the enumeration or the functions. We can just extend or whatever. Okay. But how can we leverage the functionality of the Gantt agent to actually do things like not spam the users or the server? How can we have a Gantt chart that the agents share to know that they don't need to send an email twice? Those kinds of advanced functionalities. Okay, so now we see that it's still the email task agent is just handling everything. This is still just one agent handling every email. Period. How could I have a swarm of these agents coordinating? What if other people were running these agents off of their computers to help me? Right? We got to get the AI to think a little bit bigger. Okay, so celery's good. But it's an external dependency and it's a pain to set up. Trust me. This is where our good friend Dapper comes in. How could we use Dapper and things like distributed locks, workflows, and other advanced features to represent this functionality? So still, does use any of the functions. What do I need to tell you to get you to understand what I am trying to accomplish? Yeah, and so I have some workflow code from Dapper. Where is it? Dapper Python SDK, I think. Yeah. Examples. Workflow. Yeah, this is cool. How could we use the Dapper workflow to help us manage this? I also want to use the Gantt pattern in order for the agents to be able to coordinate their behavior. Let's call them workflow agents. It's like, I know that this is not something that requires agents to solve. There are much simpler ways of doing this, but the whole point is we're trying to get one working use case. Yeah, see how it's like doing it a completely different way? And that's fine. Right? Like, this is totally fine. So, I'm recording a YouTube video and trying to explain why this is a relevant example. Period. The challenge with just using the workflow client is that it lacks advanced functionality. What functionality would be enabled by getting the Gantt agents operational? Because that's the thing, like why. And let's just throw in a why, what, how as well. Right. Yeah. See, so setting up the tasks and keeping other things updated, right? So let's ignore the requirement of the Gantt agents actually sending the emails and delegate that to a separate system, period. How could the agents help in terms of tracking what's going on, managing other systems, or perhaps writing the code for other workflows? That'd be a way to think about it. Let's spread it out. Oh, we're going to be adding so now let's imagine that these Gantt agents are keeping data in sync across Google Sheets and Notion. What might that look like? How could it write its own code using GPT-4? So this is where our writer and retrievers come into play. So now let's look at our writers and retrievers. Our Google Sheets retriever. Oh yeah, so we're going to definitely need a Notion writer retriever. Change the examples used by the Sheets writer and retriever to be Gantt related instead of book related. Yeah. Kind of burnt, so I can't really like connect these dots, but the dots are getting pretty close to connected. So I think what I'll do is I'll just keep talking, and we'll put these ideas together. Now show the agents keeping the Google Sheet of Gantt tasks in sync with the workflows and Redis. What's up, AI developer? How you doing? Oh yeah. I'm trying to figure out who that is. But yeah, what's up? How are you doing?
Good. I'm not sure what exactly this channel is about or what you guys do here. This is my first time here, but
Cool.
curious to hear what you're presenting.
Yeah. So, what I do is, well, first, how much do you know about DSPi before I get too deep into it?
I mean, I did a complete cheat sheet yesterday, and I've already started working on it today. So I consider me as a beginner for DSPy.
Okay, beginner, you're saying.
Yeah.
Okay. So what use case do you have? Like, I'm sure you probably have a problem that you're trying to solve, or are you just like...
Yeah, so I'm doing in-context prompting, basically. So we don't do general typical RAG where you have like a vector store and you go and fetch the data from there. What I do instead is we have the system basically spit out the code that needs to be written, and that's connected to a database, and that just filters the data and returns it back. And so think about it more as like text to SQL.
Yeah. Oh, yeah. Well, there's a lot of people that do like text to SQL and stuff like that. So I'll give you first. Let's start with my project, which is DSPiGen, right? So basically, DSPi started by academics, kind of towards the academic world. Me, I'm the first DSPi entrepreneur, so I do projects if people want DSPi work done, prototypes, all kinds of things. I can do that. And so what I needed was a way to quickly create business DSPi, right? So simple example, modules for text summary. You give it the text, you get the summary out. So for instance, what you're talking about with code generation, right, is you have your prompt and then you want your generated code. Or machine translation, right? Source text, target language, translated text, right? I'm sure you can see how these can be applied towards your use case, right?
Yeah, I think that makes sense, the code generation piece. I mean, it's still definitely one part of the equation. But also, if I were to adapt it to go from prompting to SQL, but I don't want SQL, maybe let's say I want some type of a distributed system like maybe Spark or something, I should technically just be able to use something like this, right?
Yeah, well, and I'll go to we'll go to the next level of degree of difficulty, which is composing these, right?
Right.
So I already have a ton of these modules. So for instance, we have SQL query module, right? Let's see. So we have super simple DSPi, old query, improved query, right? So what my modules that get created have is they have CLI commands. So you can do a DSPi module new help. That's not the new help, just module help. So I do this kind of like dynamic loading of the modules, so you can just call them from the CLI. That's one, makes it super simple to use it other places. Two, I create these fast API routes so that you can also, across your entire network, Kubernetes, Docker, whatever, be able to access the DSPi generation. And then I have these main functions for you to test with.
Yeah, I think this is pretty dope. But quick question:
Yeah, no problem.
way that DSPi works, is it asynchronous in nature? Like how does like fast API would automatically concurrently like I'm a little bit not fully familiar with how DSP under the hood works from its concurrency standpoint, but
Yeah.
will there be like a block in and out if like multiple requests come through?
Actually, you can just solve that. There's this guy Tiangelo created a syncer. So
Is it similar to async here?
yeah. But basically, what it does is it takes any kind of synchronous code and makes it async. So I have somewhere. So another thing that I have is an experiment folder which has a ton of projects in it. Like there's even projects of projects. So somewhere in here, I did an experiment where I was using DSPi and Soonify Grok. So this is pretty old, but if you look at this example, this is me running Grok concurrently. So you have this async function. It runs DSPi inside of it, and it runs it concurrently. So this is probably what you'd want to look at in terms of getting. Let me open this in GitHub. If you're trying to do async, like concurrent DSPi, this is it. So you got this.
So basically, you would just have, however, you have your regular methods and function, and you just use the asyncer to wrap it around as an async function.
Yeah, you create this task group, and then you do Soonify on the method, and then you give it the parameters, and it handles all the concurrency. So whenever somebody says like, "Oh, it's not concurrent," or "I need it to be concurrent," I'm like, actually, you don't. You just use this and you move on with your life.
Gotcha.
So there's that.
And so DSPi Gen is your library, correct?
Yeah. Basically, I commit tons of code. I think there's over 200,000 lines of code in this.
Is it fair to say that yours is like a starter pack from the get-go? Like, I don't need to do all the heavy lifting. I just need whatever. And from one line, I should be able to set up everything.
Yeah, I mean, the thing about it is this is more of an exploration of how to get things done with DSPi. So it's not so much like, I mean, if I had help, it could be more of a framework where it's like, all right, here's how you do a DSPi project. I think it's more of just, I'm a guy that I have like 24 years of programming experience, so I know there's certain patterns that you need no matter what. And I build projects for people, prototypes with DSPi. So
what is your take on DSPi so far? Do you think that it's a little premature right now in terms of like, because I need to build the entire stack for my company, and I mean, there's obviously I could do it on LangChain, Llama Index, or I can even do it from scratch. But let's say you build it out on DSPi, do you think that there'll be technical debt that might get incurred in the future?
No, I don't think that there's any other way of doing language model work. I'll put it that way. Mm-hmm. Like literally there's no other way. Like if you try to do it any other way, you're definitely going to be running into problems. So that's the thing about DSPi is I was doing my own frameworks, own projects, all this stuff when I came across DSPi. So another thing about it is it's not like I just discovered language models and I just started making programs. I trained my own text model for generating text about 8 years ago. So this is more of the continuation of the quest that I've been on. And so this is the best model of it. So the thing is that, like, if you're trying to do Nuxt, for instance, like I have like chatbots that can do Nuxt. I have a ton of other projects as well. I do everything open source. So, for instance, I have like if you want to do the DSPi patterns in JavaScript, I have a package for that. If you want to know what a full Nuxt project, which is like kind of like Next but way better, my project's open source for that as well. So
yeah, I'm gonna check out your repo for sure.
Perfect.
Do you think that how long would it take for you to set up something from text to Spark or text to Polars as well?
Well, I got something for you on that point as well. So I have in here this retriever that I was just working on today, actually, this data retriever, and you can see that I can this is one of the patterns that I love about DSPi. Isn't necessarily like all the work. So for instance, I only use about 5% of DSPi. We could put it that way. But even in that 5% is much, much more powerful than any other framework, period. To where the point I say I don't even look at the other ones. Like every single time I look at it and I see a system prompt, I say immediately, this is not it. But anyway, I'm sure you could see from one of these data formats some familiar things, right?
Yeah.
So the thing about it is, with this data retriever, there's a forward function with a query. So what I was able to do was found a library that allows me to do SQL against any pandas data frame. So this is basically, you give it a file path, and then you can do your SQL queries against it. So the first example I was working on today is a Google Sheets retriever, right?
Right.
So now I can pull down any Google Sheet and start doing SQL queries against it as if it was any kind of database.
Right. So if I were to ask you, let's say we have a Redshift or Snowflake data warehouse, and you have a massive amount of data over there. Let's say 10 million records at least. And currently the system that I'm trying to implement it is obviously it will have cache data loaded into a pandas data frame.
Yeah.
And then based on the user's language query, it'll automatically try to filter, run the code against it, and then kind of summarize basically doing a data analytics type of things. But the challenge that I've been facing is SQL is not really cutting it off for the types of questions. Panda, however, is. But as you know, Pandas runs on a single core in comparison to running it multi-core. What I would technically try to do is either directly go from running directly pandas to running polars, or directly querying and getting the polars code instead of going through pandas in the first place. Do you have any recommendations?
Yeah, I mean, so the one thing is, in terms of my background, is I came from working on the data lakehouse for Intuit. So we're talking about over 100,000 tables, period. Right. So, and the world's largest so I know about like big data. And so basically what you're looking at is two problems, right? I would separate I wouldn't use the way I talk about it, right, is Python is really good as kind of a glue language, right? So I think about it as the manager, right? But then you'd want to filter down to the workers, Go or, Erlang or what, Java, whatever. But you don't want to try and do the heavy lifting in Python. You're just going to drive yourself crazy. But Python's really good, and there's something that I look at called Dapper, which is distributed application runtime. It makes it really easy. So for instance, I have a module in here that does, I was looking at Elixir for a while. I just couldn't find a good IDE for it. But I had a 2 Elixir, I think it was. Yeah, 2 Elixir module. So for instance, this is what it looks like to change my Python code into Elixir using DSPi. That's literally all that it took.
Oh, that's perfect, yeah.
So that's kind of the reason why I say, well, and in reality, it actually kind of doesn't matter, because if I can just have an endpoint where no matter what, code gets turned into a different language,
right?
It does.
You would just convert that into that language and then compile and run that, execute, get the query back or the results back, and then you're pretty much done that way.
Yeah. Well, and another way to think about it is with you're saying you weren't using vector databases, but if you think about it, this is something I did at Intuit, is in reality there might be only, let's just say for your use case, like n number of total queries that humanity could ever create, right? Let's just say it could be 1 million, it could be 100,000, it could be 10, right? There's some upper limit. And so if you had a way using vector embedding to figure out, and maybe some but figure out what somebody was looking for, you wouldn't have to use the language model to the generation, or you could just do all your generation with the language model ahead of time, right?
Yeah, we have that piece sort of like puzzled in as well. It's just that when a new query that sort of comes in, then it requires the computation piece of it. That's kind of where, Pandas has been doing a good job. We need to sort of scale out of that lower piece. There's definitely a good thing about Polars is that it's built from scratch in Rust, so it's extremely fast that way. But I do think that there's definitely something in DSPy where you can build that piece of the pipeline and connect it into my system, so it automatically does all of that work intermediately.
Yeah, that's the way I think about it. Is that DSPy takes prompting. So that's the thing is, so what's funny is people usually skip over this part, right? And to me, this is the most brilliant part of DSPy, right? They talk about like optimization and they talk about metrics and all that stuff, and I'm like, that's not it, right? And it's this, right? Like this is good. This with the chain of thought prompt is good enough, and you use GPT-4o, you're good for pretty much everything, right? And so for your use case, right, it's probably not, your company doesn't have a problem paying the GPT-4 price for one of these queries, considering probably how much your customer's paying for whatever system you're doing, because it sounds like it's expensive. So
we don't have restriction on the pricing piece, so we're good on that front. Even for the tests we were using, not even 4.0, we're just using the 4 turbo, so it's like the most expensive that you can pay for. Results are really good. We're just more hitting the challenge of this concurrency and compute time where you need to like process even faster. And Pandas and SQL. SQL, the good thing is you can also run it directly on Snowflake compute and you can control how fast that gets processed. But it's not as quiet. Like if you do more like system 2 type of questions, then it gets way crazier, and you want to sort of bottle it back to something's a little bit native to Pandas, basically.
Well, here's another thing that I've been doing in terms of my patterns is my agent framework. Basically, I use finite state machines. So the thing about it is, like most agent frameworks, you're using language models and hoping that it gets into the state that you want it to get into. And I'm just saying that from one state to the next, you can own. So that's what I was saying is, like, I feel like I've solved the control problem for AI, right? AI agent. And what is the control problem? Oh, well, it can do whatever it wants. We don't know. Well, actually, if you just make it a finite state machine, it can't do anything other than what you want it to do.
Correct.
So that's one of the other things is that, and you don't even have to use it as an agent, but I basically came up with a Python mixin where you just add these trigger decorators to the functions along with, you have your enumeration.
That's awesome.
Yeah, this one here, right? So this is a sales process, right? And so you just have all your things listed. And then what you do is you can have this prompt so the agent can figure out what state to transition into based on unstructured text as well. So let's just say that you had your use case. Actually, I was going to say the one thing in return for me helping out with this, if you could subscribe to my YouTube and maybe like drop a comment, that would be all the payment that I need for what I'm about to show you. Because what we're going to do is we're going to go and I'm going to like show you the code for, I think, what you're looking for. And we're going to come up with a new use case for the agents. So I'm just trying to explain what I'm thinking of, right? Is I'm dealing with a system requiring massive amounts of data queries for things like Snowflake or Spark. And I need to be able to take a natural language query from a person, create it into a intermediate language, and then run that process to get the result back to the user. Period. Can you create the enumeration for this agent? No other code. Right? So let's see what it thinks about what that'd be. Okay, so here we go, right? These are pretty much the states that you're looking at, right? So then we can say, okay, and then what we can do is we can use the data retriever. Actually, we'll use that this grok example that I have. Well, no, we won't use that one yet. We'll just do the data retriever that I have. Data retriever. We'll grab this, and then I'll also show it the Google Sheets retriever. That's the writer. We need the retriever.
What does the retrievers do? Do they just like retrieve information?
Yeah. So the other part of beauty of the framework that I like is the concept of the forward function, right?
Great.
So if you go to any module in DSPi, it will have a forward function, which, much like the strategy or the command pattern, is the whole point of it is that you have one function that you execute no matter what, right? So the whole point is, if I give you a data retriever and you use the forward function, you know it's going to retrieve data. And then you know if I have a Google Sheets data retriever, you know that if you call that forward function, it should behave exactly like what it descended from, right?
Right. Yeah, it's very similar to PyTorch, basically.
Well, it was actually 100% built off of PyTorch, right? And once you have that simplicity, you can then build. So, but let's just say that we have that now. So I also have, I don't know if you use ChatGPT, but one of my favorite things that I built was the ChatGPT Chroma DB retriever. So this will take your ChatGPT logs, put it into a Chroma DB, and then you can run queries against your own ChatGPT history.
Okay, gotcha.
So there's that, but then it's in the same DSPi format, so you can use it. So we have a retriever, we have our Google Sheets retriever, right? And so now we're going to say, can you create the snowflake retriever?
So it does the similar thing, but with Snowflake now.
Exactly, right? And so, but what we can say is that we'll go to the 2 Elixir module, and I'll give you this conversation after we're done. Now I need you to choose a language for the intermediate step, since running pandas is too slow. Okay, so Apache Arrow, right? So
I think PyArrow might be not the best, but let's kind of see. I mean, if you can also tweak it to, like, instead of doing PyArrow, can you just directly give me a Polars?
Polars, you got it. Perfect. So, I need you to create a module that uses the Polars language in order to run the subqueries instead of pandas. Cool. So now we have
Get Polars, basically.
So here it created a module, a query module. So you give it a socket.
But it's not imported Polars, though, right?
No, it's running it against a. The thing is, you could be running a container in like Docker,
Right.
to have your Polars. So you wouldn't want to necessarily be running it on the same process anyway.
Oh, right. Okay.
So we'll do a quick version of that too. Like, can you create a Docker Compose file that runs both of these systems together, connected by Dapper? Dapper is really awesome for the cross query stuff.
And Dapper is open source?
Yes. And I'll do even one better. Can you create a Mermaid.js diagram of this entire system for a non-technical person? So I'll do is, before I forget, I will share this conversation with you. So I think this probably takes care of a good percentage of what you were concerned with, right?
Yeah, I'm gonna sort of like look into this. Obviously, I'm gonna both subscribe and like your videos and channel.
Comment too. Comment. That's that my intern says that's the most important one. So comment. I say controversial stuff like, for instance, I hate VS Code. It's terrible. I'm the greatest programmer of all time. I got all kinds of other stuff.
Yeah. No, all good. But this was super helpful. Like let me sort of like it's my journey started with DSPy literally yesterday.
Yep.
I'm gonna definitely like look into it. Seems very robust. The team behind it is also like really dedicated.
Mm-hmm.
And there's obviously a lot of frameworks coming out right now. But if you're building out these things fundamentally, I want to make sure that changes don't happen so rapidly that it breaks out, because we have multiple clients that we need to serve this for.
Yeah.
And the last thing we want is that it's breaking or something like that.
Yeah. Well, I am for hire for both consulting or otherwise. So
that'll be great. So can you like drop whatever your website or URL?
Oh, my LinkedIn. So one of the things is that I have a LinkedIn newsletter where I also post all kinds of stuff.
Where are you based out of?
Los Angeles.
Okay, gotcha.
So that's my newsletter. There's, for instance, one research paper that a Strader put up where people are just kind of coming up with these techniques that I was doing back in November. So there's 550 of these newsletter articles. So I've been in the game for a while. But yeah, no, feel free to drop by if you have questions. Feel free to hit me up here. Yeah.
Sounds good.
Cool, man.
Awesome. Thanks a lot for your time.
Yep. Have a good one. All right. That was a good session. Help somebody out. The thing that's interesting about that exercise that I did with him, for instance, is what did I gain, right? Because you might think like, oh, well, Sean, you should have hit him up for some money. Well, what it did actually was the technique that I just showed of me going through all my stuff, that is a sales pitch, right? So he's helping me practice. He didn't sound like a CEO of a Fortune 100 company, but the pitch that I just gave him is almost the exact same pitch that I would give to a Fortune 100 CEO. If that CEO was technical, they'd probably be able to follow along with what I said. And on the fly, I was able to develop a solution to his problem and learn about technologies that I'd never heard of. I'd never heard of, Polar, right? So now he helped me in terms of like, now if I find other people that have a similar problem, he didn't give me any secrets or anything like that. It's not like, that's why I was able to like give him these things right away, is these are common problems, but unless you're using DSPi, you're not going to be able to come up with solutions in a performant way. And it's like, what do I mean? Let's get controversial. Let's look at LangChain, my good LangChain. Like, why do I say like so that's another, I guess, controversial statement, is that none of these other AI frameworks are even close to DSPi. Like, it's not even close. So it's like, what do I mean by that? So let's look at all this stuff. So one, LangChain is so complicated that to even be able to get something done with it, you have to invest a large amount of time, right? Because it looks so strange. If we look at the code, right, what's funny is even in this is something I was talking about before. Even in their example doesn't have anything interesting in it, right? Like there's this ellipsis is very telling to me, right? But let's just keep going through their docs. Like, let's look at what their examples are, right? It's counting numbers, right? It's the reason why if they tried to show you something that's actually like production LangChain, you would just give up right away. Like, straight up. That's why when I say these things, like, I'm not making this up, right? If you look at this, if you try to understand what this is and what you can do with it from their cheat sheet, let's look at the tutorials, right? They're really trying to push their language, right? Let's see what their first tutorial is. English to Italian, completely trivial, right? Nobody has that problem. And the thing though is that they can't show you more complicated stuff because people won't be able to understand it. It's just too complicated. So there's that, right? So trivial example. But also you notice this is just template replacement, right? Like this I could do with the F string in Python, right? Like if you were to you have to do all this stuff for something that if you were actually just using here it's even baked into OpenAI. It's not even like it's flexible to different models. So if I was just using the OpenAI API, this much simpler, right? And it would take me 15 minutes and I'm done. Whereas I'd still be trying to learn LangChain, trying to figure out what all this stuff is, right? Like it's too complicated. How-to guides, right? Turn structured data from a model, right? If we look at it, we've got this kind of stuff. We got the schema, got the invoke, right? This is pretty standard stuff. But again, here we go. System prompts. That's what I said to him. I said, as soon as I see a huge system prompt, you're done. This is not sustainable. Right? Like, how do you create these? What if you need to do a different situation? How do you know if this is even any good? Right? Oh, well, you test. You run it, and you check it. You run it, and you check it. That's where the DSPi stuff comes in. But for me, I have another element that I didn't mention to him, I should also mention, is I have my custom GPTs for these things. Right? So at DSPi signature, I have a GPT that knows how to make these things. We can look at the system prompt, right? Signature classes, then it has the essence of it, talks about different pieces. It has code relating to it, right? So that's another aspect of it that, kind of, not that I gloss over, it's just I've done so much stuff that's another reason why helping him out works, is I'm able to also go back over, okay, what did I forget to say? What is the package that I'm presenting? How am I presenting my services? How are these things getting done? So, all right, let's get back to coding. I'm super burnt for the day, but we're just going to keep going. So we were building our Gantt chart system. So now, we'll do what we were doing before. It's like create a Mermaid.js diagram of the entire system using the C4 model. And so we're going to go to the Mermaid documentation, Mermaid doc, and then we're going to do C4 diagrams, right? This is based on this guy, Simon Brown. It's pretty interesting stuff. So we're just going to copy this and we're going to paste this in here. Oop, we got a little loop coming. Oh, shit. Sorry. Got a little loop going on. Now we're connected back to Discord. Okay, where were we? C4 diagrams. Okay, so now let's look at what the C4 diagram looks like for this. Line 16, lexical error. So let's, oops. So let's look at what happened. C4 docs, mermaid. Okay, so let's run it here. Let's see if it jumps it to here. It ran, oh, okay, it put it down there. So we can go to here. We can see if it's correct. So we'll put ours in there. And, okay, so this is not correct. So we'll go back and say, this is not correct. I need you to check every single line of the mermaid to make sure that it parses correctly. Hopefully this works. It is not running. All right, well, there's also the C4 model. He has his own C4 model. He has his own DSL, the Structurizer DSL. So it's got some interesting stuff. So, yeah, C4 and UML. Archimate. Okay, I'm not going down this rabbit hole, but the thing I wanted to say is that the AI understands what's going on, right? So, okay. This all being said, what we can do is now create the Design for Lean Six Sigma project charter for our entire conversation. Yeah. So you can see how like it's creating a pretty interesting measures of success and stuff like that. And so let's say There's another kind of document. Create a statement of urgency document with specific measurable KPIs. All right, cool. So we got our statement of urgency, right? So now create the README for the project code. So now you can see that it's like bringing in part of the architecture in here. So it's thinking about the project differently than if it was just I was just telling it to do certain things. So here's where we get crazy. Create the 5-year roadmap section of the README. So here it starts expanding, right? Dedicated innovation lab. I'd love that. So now working backwards through the roadmap, starting at year 5, then going to year 1, rewrite the README. Yeah. So actually, no. And what we're going to say is start with an executive summary of year 5 through 1, period. There should be a paragraph of summarizing each year. Okay, so now we're having the AI plan through these things differently. I think this was along the lines of what you were mentioning earlier. And so, yeah, I think this is what I was saying when I was like, yeah, I think we're on the same page with a lot of this stuff. But I think also that really there's only so many ways to do these things, and that's kind of what one of the philosophies that I'm operating under is that all systems. Oh, this is another good bold statement for me to make for the shorts, is that I believe that all systems will converge around my ideas because my ideas are the best on the planet. Period. The end. Put that on your Instagram or your TikTok. All right, so now what we can do is create the project structure section of the README. Actually, let's first talk about. I like the idea of the innovation lab. It mentioned a dedicated innovation lab. So let's play around with that idea. So here's how we do it. Let's create the README for the fully automated AI agent innovation lab. Why not, right? Shoot for the stars. Yeah. Now, so let's do this. Create the help synthetic help for the Innovation Lab CLI. Because this refers to what I was talking about the shape of the problem, or not the problem, but of the situation is, I'm tired. I don't want to implement these things, but let's talk about everything out here so that maybe we can draw the line. Oh, actually, let's first do the CLI, and then I'll explain my theory to the AI. The AI will be able to continue. I'm describing the technique that we're using right now as hyperdimensional circumference mapping. Period. What I mean by that is that if I'm able to define all of the documentation for a system that does not exist except in my hyperdimensional mind, period, that then generating the code to make those systems exist becomes much easier. Is my theory correct? Are there other theories to support this? And what should I know that I don't know yet? Yep. Okay. Did you know some of the formal methods? Yeah. So. Sure. I think I'm running out of steam. So I think covered a lot of ground, and I'm going to share this conversation, create a link. Paste the link, and I think I'm going to call it for right now. I'll take a break, might walk the dog's asleep, watch some TV, maybe come back later tonight. So I'll see you guys later.